In this video, we're going to take some notes on curve fitting, and we're going to be using our Casio calculators to do that. So in this one, we have a table over here, and this table has the number of homicides in the United States each year from 1935 through 1970. And this is the year over here in the first list and the number of homicides in the right list. It says create a scatter plot of the data using the number of years since 1900 as X. So that's our X list right here. But instead of putting in the actual year, I'm going to simplify it because my calculator gets a little confused when I enter such big numbers. So 1935 would be 35 years, 40 years, 45 years, and I'm entering the number of years since 1900. So basically I'm just leaving off the 1900 part. Okay, and this is what's going to be my X value. It's what's going to go in list 1 in my calculator. And then the number of homicides is Y. So the number of homicides is going to be over here. That's going to be L2, my list 2 in my calculator. So in my calculator, I need to come over to the Stat menu. Be sure you're in the one that says Stat. It's not necessarily the same on your calculator, but the list menu does not work for this, or the table menu, just the Stat. So it says list 1, and I'm going to enter my elements. I enter 35, hit enter, and then 40, and so on. So you might want to pause the video for a second and be sure you get everything in list 1, and once you're done with that, just hit the over button and enter everything in list 2. It's real important when you think you've got them all in there that you double check you have 8 things in list 1, 8 things in list 2, or nothing's going to work out. So pause the video if you need more time to enter them. All right, so what I want to do is I want to see what this looks like. So I'm going to graph it. So I hit F1 to go to graph, and then my calculator's automatically set up that graph 1 is a scatter plot, so I can just hit graph 1. When I look at this, I look at the shape of my data. Of the functions that I know, this looks pretty U-shape, so I'm going to choose a quadratic as the curve of best fit. You can also tell that because the title was quadratic curve fitting, by the way. But what we want to do now is calculate the equation for the curve of best fit. So I hit F1 to calculate, and I have options. If you look on the bottom of your screen here, you have linear, which is y equals x. You have a median fit line. You have y equals x squared, which is quadratic. You have y equals x cubed, which is cubic. You can also hit F6 for more options, and you can see we have x to the 4th, logarithmic, exponential, all sorts of things. Right now, we're just going to do quadratic today. So I'll go back to my quadratic, which is x squared. So I hit F4 to get that down. You can see this gives me some information. It gives me A, B, and C that I could fill into my quadratic standard form down here. So I have y equals, I'm going to type in A, 20.5364. I usually give 4 places after the decimal. Then our B is negative 2018.3035, and that has an X with it. And then our C is added on the end, which is positive, and it's 56,392.875. Sorry, it's hard to see that decimal point in there. All right, so I'm going to write down that equation. Some other things to point out on this screen is I have right here an R squared. This is our correlation coefficient. It tells us how good of a fit the quadratic is, with a 1 being a perfect fit. So a 0.92, that's a pretty nice fit. So it asks me in number 3, what does the scatter plot indicate that this type of function provides a good fit? And that would be because it makes a U-shape. And our U-shape was the parabola that was quadratic. All right, we're going to want to do things with this equation. So I'm going to do 2 things right now. If I hit F5 to copy, it will take me into my y equals. If I hit execute right now, it's going to paste it there. I won't see it happen, but when I hit execute, if I go into my graph menu, it'll be there. I can also hit F6 to draw the function, and then you can get an idea of how well it goes through the points. And we can see this looks like a pretty nice fit. All right, number 4 says, according to the curve of best fit, what was the least number of homicides in the US, and when did this number occur? Well, we know that the least happens at the bottom or the minimum of this parabola. My calculator is really good at calculating that for me, but in order to do that, I need to go over to the graph menu. Now, mine is not selected, so I need to hit F1. If your graph already had the little equal to with a square around it, then you don't need to hit F1, but just be sure you're selected. And then I can go to draw, and there's my parabola. Now I have all the buttons available at my GSolve. So I want to find the minimum. I hit GSolve minimum, and I get an answer of x is equal to 49.1396, and y is equal to 6,803.5648. All right, so that's a number that my calculator gave me, but I need to answer the question in real life. In real life, it says, what was the least number of homicides? So I probably can't have a half a homicide. So let's say 6,804 homicides. And when did this occur? Well, the when part would be the x value in my equation. Remember, my x was really the number of years since 1900. So this would have happened in 1949, we'll say. Okay. All right, let's see what else we have on here. Number 5 said, how was this point evident on the graph? And our answer, it was the minimum. Remember, this thing is also called a vertex of the parabola. Good to review vocabulary before SOLs. All right. Number 6 asks, what are the algebraic domain and range for this function? So I'm purely going to think about my y equals. I'm not thinking anything real life, just algebraic. Algebraically, this thing makes a U shape. It goes forever to the left and right. So its domain is all real numbers. The range are the possible y values. For the range of a function, I look from my vertex, this thing only goes up. So I have to say y such that y is greater than or equal to, and I need the y value of this vertex, which was my 6,803 point whatever homicides. If you rounded that, I'd be fine with that too. So that's purely algebraic. Number 7 asks, what would be an acceptable real life domain and range for this function? Explain your reasoning. Well, in real life, we have to think about what the domain and what the range are. X is the domain. The domain is the number of years since 1900. The range is the number of homicides. We also call these sometimes the practical domain and range. In other words, in real life. So if x is the year since 1900, what kind of years are going to make sense in this function? Well, that depends. Should we allow ourselves to keep going negative for x? Maybe we could go before 1900. It starts to enter the zone where it's no longer realistic if we go too far outside of our original window for data. So really for this one, a real life would be maybe, the years should be between maybe 0 and 100-ish. That would take us up to the year 2000. You could have a smaller window than this. Just realize that x is the years. Y is the number of homicides. So y should be positive. Technically, we could have no homicides, but it could go up from there. We could have lots. All right, number 8 says, what is the y-intercept for the curve of best fit? Well, there's 2 ways we can find this. We can go into our calculator, and under GSolve, we have a y-intercept button. When I press that, however, I get not found. Why do I get not found? Well, if I look at my view window, so I go Shift View Window, I can see my x-min was 29. I would need to make my x-min 0 to go all the way back to 1900 or to get the y-intercept. If I do that, I can graph, and oh my, it's not even close to being in the picture, but if I hit Y-intercept, it'll still find it. And what I have is 56,392.875. How else could I have known what this number is? Well, if I look up at the top of the sheet, you can see it's the C value, the constant on the end of my equation, and I know that for everything, that's the Y-intercept. So that's the Y-intercept, purely the Y-intercept. Number 9 says, how can you recognize the Y-intercept from the equation? It is the constant on the end. Or what we called C in standard form. If we turn over the page, it says, how can you find the Y-intercept on the graph? That would be where the graph hits the Y-axis. Again, we had to adjust our view window. And number 11, what does the Y-intercept represent in real life? Well, this is the Y value when X is 0. So in real life, what this means is according to our graph, in 1900, there should have been 56,393 homicides. Does that really make sense? Do we think there were probably that many? No, probably not. And what I might want to do once I've answered this question is really go back to this real life domain and range I had, which was number 7. So I might change. Maybe my years starting all the way back at 0 doesn't make so much sense there. Maybe I'd want to start somewhere closer to 20. I also might not want to go up to 100. You know, this is flexible. It's really just making sure you think about the data. Okay, let's go back to 12. What is or are the zeros of the curve of best fit? Well, I can go to my calculator again. I can go to G-solve. I can hit the root button. Oh, it says not found. How come? Well, let's look at the picture. Where does this hit the x-axis? It doesn't hit the x-axis. So there are no real zeros. Okay, this is a quadratic. It would have 2 imaginary answers in there. How can we recognize the real zeros on the graph? Those were the x-intercepts, or the root if we used G-solve. Number 14, explain how the graphical zeros and the algebraic solutions relate to the real-life meaning of this function. Well, what does this mean? If y equals 0, that means there's 0 homicides. So what we're asking is, when were there no homicides? And that was never. I'll write that down. Okay, so let's see what other kinds of questions we have on here. Number 15 is asking us, according to the curve of best fit, how many homicides should have occurred in 1976? So what we're looking for is how many homicides. So we're looking for a y value. That's what we don't know. We have to tell the calculator what x is. Well, in 1976, our x would be 76. So I've got a couple of ways I can do this. I could go into my table and put in 76, or I can look at my G-solve. If I hit F6 for more options, there's a Y calculate, F1. It says Y calculate, so it's asking me what is X. X is 76, and oops, it says argument error. How come? Again, this is because if I go back, my view window is not going to be big enough. So I need to go to, let me exit, go to the view window, shift view window. My X max only went up to 75. In a lot of these real life problems, we're going to need to adjust our view window to give us more things in our domain. So I upped my Y max to 100. I can draw this again. And now if I go to G-solve, hit F6 for more options, I'm looking for Y, so I hit F1 to Y calculate. It asks me for X, which I know is 76. I hit enter, and it tells me that Y is 21,620.215. I like to write down the nice decimal answer and then also say that that would mean 21,620 homicides. How can I find this algebraically? In number 16, I would plug in x equals 76 to the equation. So if I wanted to, I could also do that in the run menu and just plug in 76 for each of my x's. But that'd be kind of a pain. It's easier to use the calculator to do it for me. All right, number 17 asks, according to the curve of best fit, when should 20,000 homicides have occurred? So we're looking for a when, so I'm looking for what x equals. When there's 20,000 homicides, that means y is 20,000. Well, where do I usually put in a y equals in my calculator? Y equals was on the regular screen in the graph menu. I can put in y is 20,000 and I can draw this. And I can hardly see this line in my picture, so again, I might want to go to my view window, shift view window, and maybe I want to go up here in my Y max and make that a little bigger. I'm going to make my Y max 21,000. The other thing I could do is a zoom auto or a zoom fit. But so long as I can see, I've got, two intersections. Why do I have two intersections? Well, I have one on the left and one on the right. So on my calculator, I can go to GSolve, ISECT, and it will tell me where they are. The first one was at x equals 23.7903. And then if I just hit the over button on my calculator, it'll go to the second one. The second one was 74.4888. And then I need to answer when is this? This would be in 1923 and 1974. Again, you can make arguments for rounding either direction, but usually there would only be one answer here that would make sense. Okay, so that was everything for our curve fitting problem. The big challenge that you guys have with this is, first of all, when we go into our stat menu, you want to be sure that you only have the original things in your list you want. If you want to get rid of a whole list, you can go hit F6, and if I hit delete all, it will wipe out the whole list. Or if I accidentally want to hit just one thing to get rid of, I can hit F3 to delete one item at a time. Or I can hit F5 and I can insert if I skipped an item. So I can use this just like a regular spreadsheet. I'll delete all to clear that out. So for next time, I start with nothing. Always make sure you have the same amount of data in your two lists. And then when you're graphing, if you're trying to do prediction stuff, be sure you adjust your view window. Just because your calculator says not found doesn't mean it doesn't exist. Okay, we'll get a lot more practice with these in class, and you need to be comfortable pushing the buttons yourself and knowing the keystrokes that you need for your calculator. So let me know if you have any questions later.